Hello students, in this video we're going to look at topic 1.7 from the syllabus, powers of complex numbers, and this is going to lead us to DeMoivres' theorem. So let's start with this idea of finding the first power of complex, the first power would be z to the first, yeah? But then let's think about z squared. So z squared is going to be our complex number multiplied by itself. So I could say that's magnitude z cis theta times magnitude z cis theta. And as we previously learned, I can just take my moduli and multiply them by each other. So I'll get magnitude z squared. And then I take my arguments and sum them. So I'll get cis 2 theta. Now if I wanted to find z cubed, well of course z cubed is just z squared times z. So I'd get z squared cis 2 theta times magnitude z cis theta. And then applying the same rules of products, I multiply my moduli together to get z cubed, and then I sum my arguments and get 3 theta. Well, as I hope you can see, there's a pattern developing here, and that general result for z sub n is going to be magnitude z to the n cis n theta. And this is what we call DeMoivres' theorem. Now I can prove DeMoivres' theorem with induction, and I've already written this out for you so you don't have to watch me write every sentence. So we start our induction the typical way, and that is to prove that it's true for n equals 1. So of course, z to the first is just z cis theta. That's true. And then we assume true for n equals k. So z to the k is magnitude z to the k cis k theta. We let n equal k plus 1. So z to the k plus 1 would be z to the k times z. I use the previous statement to fill in z to the k, multiply it by z, and now I use what I know about products, so I can multiply the magnitudes and then sum the arguments, and I end up with z to the k plus 1 equals magnitude z to the k plus 1 cis k plus 1 theta. So since true for n equals 1 and shown to be true for n equals k plus 1, our theorem is true for all n element of integers by mathematical induction.